Hello and welcome to the A-Level Chemistry Lecture Series. Now, with A-Level lectures, we're going to see something a little different than with the AS Chemistry Lecture Series. And that's this right here. Every chapter in A-Level Chemistry, or at least most chapters, are related to one or more of the chapters that we covered in AS Chemistry. For example, in this video, we're going to start chapter 19, which is going to look at lattice energy. Lattice energy is a type of enthalpy change, and so it continues from chapter 6 in the AS material, which was enthalpy changes. So before you watch this video, it might be beneficial to go back and watch the videos for chapter 6 or read the chapters in the book. Let's get started. So chapter 19 has 4 different sections in the book, and then it has one related practical, which is probably the most varied practical in all of AS chemistry. So let's start with the chapters sections. So section 1, we're just going to briefly in this video look at defining lattice energy. So what is the definitions of a few quick points we can get on the test. In chapter 2, section 2, we're going to look at the enthalpy change of atomization and electron affinity. Now, these are 2 new enthalpy changes that are associated with lattice energy. So we're going to look at that in the second section before going into the full-blown math in section 3, which is going to look at Born-Haber cycles, which are a more complex version of the energy level diagrams we saw in chapter 6. And finally, we're going to look at section 4, which is enthalpy changes in solution. So this is a bit of its own section where we look at how does enthalpy change when dissolving something. Then the related practical is going to be the calorimetry practical that we did last year. So let's just jump into section 1 for this video. Defining lattice energy. So the definition of lattice energy, like the definition of most enthalpy changes, is going to be very accurate, very precise, and can get us 1 or 2 points on paper 4. So we got to make sure that we know the details and that we memorize the definition. The definition of lattice energy, or delta H standard lat, as we should do it with the symbols, has to do with the creation of solid ionic crystals from gaseous ions. So when we look at lattice energy, what we're essentially looking at is going from gaseous ions, so ions in the gas state, to a solid lattice, or a solid ionic compound. The official definition for lattice energy is going to be the energy change when 1 mole of an ionic compound is formed from its gaseous ions under standard conditions. So what are some of the key parts of this definition? Obviously, we need the energy change because this is a lattice energy or an enthalpy definition. And all of our enthalpy definitions are going to have this section of the energy change or the enthalpy change. The energy change when 1 mole of an ionic compound. So this is what defines our 1 mole in lattice energy. If you remember from chapter 6 in AS chemistry, all enthalpy definitions are going to have something that is tied to 1 mole of something. For example, the enthalpy change of combustion was the combustion of 1 mole of fuel. The enthalpy change of formation was the formation of 1 mole of a compound. With lattice energy, because we're forming solid ionic compounds, with that 1 mole is tied to the 1 mole of the ionic compound being formed. And then the other part of this definition is going to be that it has to be formed from the gaseous ions. Now, because this is a standard enthalpy change, obviously we have to have under standard conditions, but we do need to show that it's formed from the gaseous ions. So very, very precise with the definition of lattice energy. Energy change when 1 mole of an ionic compound is formed, specifically, from its gaseous ions under standard conditions. Sometimes we'll see this instead of saying ionic compound, it will say 1 mole of an ionic lattice. That's also perfectly fine, but just make sure you don't forget that 1 mole. Lattice energy is also sometimes called lattice enthalpy. Those words are basically interchangeable at this point. And it's always going to be exothermic because we're dealing with the creation of bonds. Think about it. Gaseous ions are independent of each other. They're ions in the gas state. There are no bonds between them because you don't have a lattice. And so there are no bonds to be destroyed. On the other hand, when we form a solid ionic compound, we are creating ionic bonds. So we're going from no bonds in gaseous ions to the creation of ionic bonds in the ionic compound, in the solid ionic compound. As we remember from chapter 6 last year in AS chemistry, the creation of bonds is always exothermic. So lattice enthalpies or lattice energies are always going to be exothermic. They're always going to release energy. The lattice energy can be represented by equations that you're going to have to come up with. The equations have to have a few things that you should always check for. Number one, gaseous ions in the reactants. Everything in your reactant side of these equations will have to be ions in the gas state. On the product side, you're always going to need to have a solid ionic compound. So ionic compounds like sodium chloride and magnesium chloride under the solid state. These are always going to be 1 mole of those ionic compounds because that's in the definition. And then finally, we always need to make sure that we have the right ratio. So for example, if we were to write the enthalpy change or the lattice energy equation for sodium chloride, we'll put 1 mole of sodium chloride solid in the products because that's our solid ionic compound. And then in the reactants, not only will we have to put the 2 ions that make up sodium chloride, the sodium plus and the chloride minus ion, as well as them being in the gas state, but we will need to make sure that we have the right number of these ions. Because sodium chloride is a 1-to-1 ratio between the sodium and the chlorine, we have a 1-to-1 ratio between the sodium ion and the chloride ion. Magnesium chloride being a 1-to-2 ratio between the magnesium and the chlorine, when we write the equation for that compound, again, we'll have 1 MgCl2 solid as our product. And then when we write the magnesium 2 plus ion and the chloride minus 1 ion in the reactants, we're going to put a 2 in front of the chlorine. That's to show that 1-to-2 ratio between magnesium and chlorine in magnesium chloride. So when we do this, we're going to make sure that we have the right ratio between those ions and that compound in the products. All right. That's about it for the definitions of lattice energy. It's very straightforward, very similar to the definitions of the other energy or enthalpy changes that we saw in chapter 6, but we just have a few different key points that we need to look at. And then we gotta make sure that we're able to create these equations regardless of what compound we are asked to make the equation for. All right, that's it for this video. I will see you all in the video for section 2 of chapter 19.